Okay, so today, statistics. Awesome. So, what is statistics? This might sound grammatically incorrect, like maybe I should say what are statistics, but this is actually right. Actually, the other form could be correct too if you're talking about something different, but since we're using the singular, what is statistics? Some of you have got to have an inkling of what statistics is.
It's a science to analyzing data.
It's a science for finalizing data. What do you mean finalizing?
Analyzing.
Analyzing, okay. Yeah, okay. That's much better. I was like, finalizing. It's a science for analyzing data. Okay. What else? Like what type of a science? Are we going to be talking about like DNA, stuff like that? It's like a biological science? It's a mathematical science, right? So statistics is a branch of mathematics concerned with describing and drawing inferences from data. So he mentioned analyzing data, right? We analyze data to do what? To describe it and to draw inferences. So, let's talk about some statistics. So, who doesn't mind sharing their GPA? Anyone mind saying like, oh yeah, I have a 3 point whatever, or 1.2? Okay, so my first semester of college, I got like a 1 point something. It was really bad. It was like a B+. So, let's say it was a 1.2. That's a statistic. What does that do? Does that describe data, or does that allow us to draw inferences from data? What type of statistic is that? It's an inferential statistic. Does anyone disagree with them?
What does it mean?
Drawing ooh, that's a good question. What does it mean to draw inferences?
Make meaning.
To make meaning? But I would argue that when you describe things, you're making meaning too.
No, I mean, you have something you can say, okay, this guy is smart because he has.
Okay. So we could use the GPA to draw inferences. So you would say that, okay, someone with the 1.2 GPA, maybe not so smart. So here you are being taught by someone, you got a 1.2 give you GPA. Okay, maybe. I would have argued that this is actually a description, right? It's the average of all of the classes that you took last semester, right? You get an A, you get a 4 point. You get a B, you get a 3 point. You have one A and one B, it's a 3.5. It tells you the average, right? It's a descriptive tool. How about the distribution of intro Psych 1 exam scores? So I have all of my intro exams and I plot a function of it. I don't have a pen. Have to write it? No, I need a marker. So let's say I drew some graph on here, and I had the scores from like the lowest score to the highest score. And the height of the bars would indicate how many people got the different scores. Okay? What would that be?
Control information. Control information.
Yeah, I'm drawing the information. What am I doing? Is that like an inferential thing or a descriptive thing? It's a descriptive thing, yeah. Okay, do students taking stats in the fall do better than those who take it during the spring? This is inferential, this is different, right? We're not concerned about maybe how they did in the fall or how they did in the spring. We're interested in, is there a difference between these two things? You need to make some inference about it. Is this important? Is understanding statistics important?
Yes.
Why?
For advertising.
How so? How can advertisers use statistics?
According to statistics, if you can sell a product in fall, maybe, maybe or much more than the spring, then we advertise in fall.
Yeah, so do you see coats available for sale in the fall or in the spring? In the fall, people have a lot of coats available for others to buy. Why? Someone who's done the statistics, maybe they didn't even calculate the statistics. Maybe they were just doing some mental statistics in their head, and they said, you know, a lot of people buy coats in the fall, not too many people buy coats in the spring. So if I want to market my coats more effectively, I should try to sell them in the fall, right? So statistics can help you make money. Now it might be obvious, like, oh, it's fall, it's getting cold, you know, so we should sell more coats. But maybe there are some questions that aren't so obvious. So on websites, if you're on Facebook, you might see that you get different ads than your friends do. Why? Because it analyzes the types of things that you post. And they've done some statistics, figuring out like, oh, this person posted about a Republican. Maybe we can get them to donate to a Republican, you know, political group or something based on trying to figure out whether that post that they made was positive or negative, right? So they can do some statistics, maybe tease out things that wouldn't be so obvious otherwise. Are there other reasons that statistics are important? And this is a psychology class, right? This isn't business, so whoop-de-doo.
Peki research describing the research.
So you want to describe the results of your research? Like, can you give me an example? Like what type of research might psychologists be interested in?
Behavior.
Yeah, what type of behavior? Like, give me an example. I mean, behavior is pretty broad, right?
Yeah.
Huh?
Like Pavlov, conditional.
Pavlov. So Pavlov has this idea, right? You can classically condition organisms to respond in different ways. So maybe we want to see if we can use classical conditioning to elicit fear or love. We talked about the fear example with little Albert, right? When I tell people that I'm a psychologist, they often bring up one person's name before anyone else. Freud. Yeah. So Freud was the founder of psychoanalysis, right? Does it actually work? You don't know? So you have a lot of people out there giving people psychoanalysis to try to help them get better, right? Does it work? We talked about placebo effects in intro. Maybe it's just a placebo effect, right? How do we tell? Statistics. Yeah, so we can use an experiment. We can have someone, whatever. We could have some trained clinical psychologists give psychoanalysis. We could have them meet with people like once a week for a couple months. And we could have someone who is not trained in psychoanalysis, but is a good listener. I mean, some people joke and they say, oh, the psychoanalysis, they're just a paid friend. You just give them money so they can listen to you, right? If that's all that it is, then we can just hire someone who's a good listener to meet with people for the same amount of time. And then we can describe how both of those groups did, and then we can try to draw inferences from them, right? So, let's see what someone who gave a TED Talk said about stats. Cool. So if you learn about statistics, you can learn how to predict the future. That's cool. The Mayans predicted the future, right? We should be all dying in another month or two. We'll see how accurate that prediction is. I would predict that we will not. But let's say we did that study with the psychoanalysts and with the paid listeners. And we found out that there was no difference. What does that mean? There was no difference. Didn't matter if you talked to someone who was trained in psychoanalysis, who knew the types of questions that maybe you should be asked, or how to analyze your answers, that made no difference. It was just as good as someone who just listened to you empathetically. Oh yeah, yeah. Oh yeah, yeah. If that was the case, what does that mean? Predict the future. Our YouTube audience is like desperately waiting. Who's going to predict the future? Fortune tellers? I think that's a different question.
What kind of future? Like you need to train what is going to be.
What's going to happen? The climate's going to change? So it turns out that psychoanalysts don't do anything that a good listener does. So this means that the climate is going to change? I mean, the climate might change, but I would argue that that would not be the reason why. I would guess it has more to do with methane gas being produced by farting cows that are produced for yummy hamburgers and Adana kebabs. So if you know that there's no difference between a paid psychoanalyst and someone who listens to you, you have no predictions. I can make lots of predictions.
Excuse me, Professor, but I think you're underestimating. Maybe these psychoanalysts, maybe they were trained to be good listeners. Maybe this is their job. So it's like someone who's trained to be a teacher and someone who's a gifted teacher. They're both, it's a job in the end. Maybe I didn't understand psychoanalysis at all, but maybe it's their job to be a good listener.
I would argue that psychoanalysts need to be good listeners, but there's more to it than that, right? If you want to do psychoanalysis, at least in America, the laws are different here in Turkey, but you need to go and get a PhD or a PsyD. You need a doctorate degree, right? Where you learn about Freud and you learn about the psychoanalytic technique. And you learn the things to do and not to do. Now, I don't know these things because I'm not a clinical therapist. Sorry. But there is something that they do that is different than just listening, right? Because I bet a lot of you guys are pretty good listeners, right? So if there's no difference, what does that mean? It's a waste of money. Thank you. Yes. For whom? Who is it a waste of money for? It's a waste of money for the patient. If it doesn't do any better to go see a psychotherapist who you'd have to pay a lot of money to, you could go someplace maybe that's cheaper where they just listen to you, right? You could save money. And I would argue if that was the case, you just find a good friend and talk to them, but you might not want to tell them about your sexy dreams. So it might be good to have like a stranger. But you could hire a prostitute to listen to you cheaper than a psychotherapist, right? So the patients can save a lot of money. Who else can save money?
Research community or science.
The research community. They could stop wasting their time and effort on psychoanalysis and spend their time and effort on more productive things. Instead of spending a lot of money and time training psychoanalysts, maybe we could spend less time and money just training people how to listen a little better, right? We could have make some huge predictions about money that we save. I would argue that if no differences were found, then in the future, people wouldn't use psychoanalysis much. Some people would, because some people use all sorts of things that have very little scientific evidence supporting them, like homeopathic medicine. Take some, water from the Jordan River, and then you put it in like a 50-gallon bucket, and then you dilute it, and then you add more water to it, and basically there's no original water there, and people are like, oh, that's from the Jordan, it'll cure everything, right? There's very little evidence that any of that type of stuff works. People do it anyway. So I'm not saying that no one will ever do psychoanalysis in the future. If that were the case, which it is, there is evidence that suggests that psychoanalysis is better than just listening. But anyway, you can make a lot of interesting predictions about the future when you've done a little bit of statistical research. Let's take a look at the Higgs boson. Let's see, start at 449. So what they're doing is they're taking a little bit of evidence here, and a little bit of evidence there, and a little bit of evidence here, and they're combining it. They're accumulating data. And they're using statistics to determine whether or not this evidence is indicative of the Higgs boson's existence. This is similar to the question we asked about, does psychoanalysis work? I can give one person psychoanalysis and see if they get better. Let's say we have a bunch of depressed people. You guys are all depressed, you're in my experiment, some of you get psychoanalysis, some of you don't. I can take a look at her and see after psychoanalysis if she's better, right? If she's better, does that mean that psychoanalysis worked? Not necessarily. I mean, people often get better just by themselves over time, right? So I don't know. She didn't have psychoanalysis, but she did worse. Does this mean conclusively that, yeah, well, it must work? No, remember when we talked in intro, we said, one, there's no proof. And two, we need evidence, right? Because there are a lot of other factors that might come into whether people get better, right? So by looking at lots of individual pieces of data, by lots of people who have had psychoanalysis, and by lots of people who haven't had psychoanalysis, and calculating some descriptive statistics and using those as a basis for inferential statistics, we can get an idea of whether or not psychoanalysis really works. That is, we can get an idea, we can get a glimpse of the truth. So, yes, it is important. In fact, statistics is so important that if you want to go to graduate school in psychology, I would strongly, strongly encourage you to spend a lot of time preparing for this class. This is one of the two classes that graduate schools, at least within psychology, care most about. What do you think the other one is? Research methods. That's exactly right. Research methods and statistics are the two classes that will, more than any other class, determine what type of a graduate program you could get into. If you do really well in statistics and research methods, you have a pretty good chance of getting into a really good graduate program. A Stanford or a University of Chicago. Do you know what graduate students are paid, or how much they have to pay if they go to Stanford or University of Chicago or U of I or any of the big, really good graduate schools? Typically, graduate students for the good schools pay nothing. Typically, graduate students at the good schools get paid to get their PhD. I got paid almost $20,000 a year, dollars, not euros, to get my PhD for free. Why? Well, there's more to it than just statistics and research methods, but I did really well in my statistics and my research methods class. So, if you want a good opportunity to get into a top program where not only will you get the PhD for free, they will pay you to do it, then pay attention and work hard in this class. If it comes down to a choice between getting an A in this class or getting an A in textual analysis too, spend your time more on this class, because this will give you the bigger bang in the long run. I'm making predictions about the future. Wow. So pay attention, work hard, and ask questions. When I present the material, I'm going to try to do my best to present it in a way that makes sense. But sometimes what makes sense to me isn't going to make sense to you. So please, if it doesn't make sense, raise your hand, because this is really important stuff to learn. Second, this is used in lots and lots and lots of other fields. For a while, I worked as a janitor in Hillshire Farms, which they make sausages, like sujuk. And they had people who were trained in statistics to figure out whether or not the machines were working correctly, or whether or not the sausage was good enough. Quality control. Quality control is all about statistics. So if you have a good understanding of statistics, let's say you get out of here and you say, you know, I'm not interested in psychology anymore. That's okay. You could get a job working in some company doing quality control. Or, you mentioned marketing earlier. You could get a job in some marketing company doing statistical research, analyzing the data that they're collecting. So statistics can not only be important for getting into grad school and for understanding what might be the truth, it can also be really, really useful for other fields. So this is a really important class. Now, my approach to statistics. A lot of books and classes are taught with this type of an approach, how to analyze different types of data. Here's some data, how do we analyze it? I'm not going to take this approach. I really don't like this approach. The approach I like instead is how to think like a statistician. Statisticians have a different way of thinking about the world. And part of what statisticians do involves this earlier thing, how to analyze different types of data, but also involves earlier things, like how do we approach statistical problems? Like, how can we figure out if psychoanalysis is better than just listening? I mean, I've said, so we look at a bunch of people, but like, what else do you need? Besides the individual outcomes. How many people do you need to make some determination about what this is? Right? Do we need 10 people? Do we need 100 people? How can we approach the problem? And why we do use the analyses that we do. So, for classes that are taught like this, you're told, okay, if you have this type of data, you use this analysis. And this used to really bother me when I was a student. Like, why? It seems so random. Well, why can't I use this? In fact, for one of my research methods classes, I actually used a statistic that I learned about in biology, and I applied it to a psychology problem, and they're like, you can't do that. I'm like, why not? It seems like the same type of thing. Well, actually, despite the similarity in appearance, there was a good reason for not using them. So we'll talk about why we use some of the analyses that we do too. To do this, we're going to play with lots and lots of data using R. So, do you guys know what R is? R is this cool little program. Where are you, R? See? R? This is it. This is R. And we are going to use R to generate data. So, R. So what I did was I just told the computer, imagine that I want to look at a set of 10 coin flips and see how many times it comes up heads. So I had it randomly do this, and it came up with 5. Let's do this again. 3, 6, 6, 4. Oh, cool. So I can very quickly generate data. In fact, I don't have to do these one at a time. I could do 100 at a time. Or 10,000 at a time. What we're going to do with this, we're going to generate data, and we're going to play with it. And by playing with the data, you're going to have a really good sense for what happens as different things change. Imagine instead of taking samples with 10 coin flips, I did 100 coin flips. Did the data look differently? Is there a difference? Let's do some quick descriptive statistics. different types of outcomes. So if we flip the coin 10 times, we could have 10 heads, right? We could have no heads. We could have 4 or 5, whatever. And then what I did was plotted how many times we observed each of those outcomes. So what we can do is we can very quickly generate lots of data and test different predictions. What would happen if this changed or that changed? And we can graphically see what happens to data as those things change. And by being able to play with the data like this, we'll get a much better understanding of why we do the things that we do in statistics. Instead of saying, oh, you need to assume this, or you need to make sure that you have 30 people or more in your group, we can demonstrate why that is. Why people recommend 30 if you're going to do studies. All right. R is free. Just like the textbooks for this class. It's free. You can download it. I will put a link to where you can download it. And on Friday, when you all have your computers, we'll make sure that everyone gets it installed and everyone can start playing with data.
Can I use it with Macintosh, right?
Yes, you can use it on Macintosh, you can use it on Windows, you can use it on Linux if you are into Linux. It's really, really powerful. So there are a whole bunch of plugins, just like Photoshop has plugins and Firefox has plugins. R has plugins. They have packages. And using the packages, you can do some really advanced type of statistical things. With this course, almost everything that we're going to be doing just comes with the base package. But it's powerful enough that if you need to do things later on in different courses, you can easily find out how to do those things. Also, this is going to really, really help you better understand what we're doing in statistics than with SPSS. With SPSS, you have the data, and then you point and click, and you say, okay, we're going to do this and this and this. And the program just sort of figures out what to do. With R, it's a bit more difficult, because it's not going to figure it out. You have to tell it exactly what you want it to do. Now, the bad thing about this is that it's a little bit more to do the it's a little bit more difficult to do the analyses in R than it is with SPSS, but it forces you to really understand what you're doing. And in terms of your ability to learn and remember this information in the long run, this is going to be much, much more valuable, I think, for you guys than SPSS. Did I mention that it's free? SPSS, like the full license, is like $24,000. R, free. And it makes pretty graphs too. Okay, so types of statistics. What types of statistics are we talking about? Descriptive? Inferential, good. So descriptive, what do? They describe data. And the inferential? Draw inferences. They draw conclusions about the data. These are based on descriptive statistics. So can anyone think of some examples of descriptive statistics? GPA. Wow.
When we change the overall stats, overall data,
Okay.
so we get like, for example, 33.5.
So what is 33.5?
Like, for example, overall the trends, or the mean.
The mean! The mean! The mean is a descriptive statistic. So if we look at all the grades and we see that the average grade is a 33, that's a descriptive statistic, right? I think that's sort of what I have for the first one. So the class average on the exam. It's a descriptive statistic, that's a mean. I mean, we can look about other types of averages too, and we will when we talk about central tendency. But the mean is the one we're going to be using most. The highest score on the exam. That's a statistic. Who got the highest? Who got the lowest? What's the range between the highest and the lowest? What's the most common score on the exam? How spread out are the exam scores? Is there more spread out in one direction than in the other direction? These are all types of descriptive measures describing what the data look like. Inferential statistics, on the other hand, they allow us to answer questions. So I taught biological psychology last spring, and Dr. Ibrahim Shanai is teaching it right now. Most of you guys are taking it. Is my course more difficult than his? We could use statistics to figure that out. Does the difficulty matter? Let's say that his is more difficult than mine. Do his students end up learning more or less? We can use statistics to figure that out. Exit polling. So when people have elections, lots of times in news media they want to report like who's going to win before all the votes have been counted, right? So what do? They do statistics. They go up to people and they say, who did you vote for? Who did you vote for? Who did you vote for? Do they ask everyone who votes who they voted for? No. That would basically be like doing the vote twice, right? And that would be really expensive to do. Instead, they look at a sample of the broader population and try to draw inferences about who the population elects based on who the sample tended to elect. Is it going to rain today? No. I'm guessing. Right? This is not really using statistics so much, but the weather people, the meteorologists, they use statistics based on whether you have a cold front coming and a hot front coming and the time of year and lots of other information that they try to build models out of to come up with a prediction. They're predicting the future. Lots of times their predictions are wrong, but they can be very helpful too. Lots of other things you can do with inferential statistics as well. Next class, we will start with probability basics. We will flip some coins. I'll flip a couple real coins, and then I'm probably going to use R to really speed up the process. We'll talk about samples and populations and probability and lots of other good stuff. Thank you.